Okay, so you have seen that if there is a raised to n that is equal to b, so its logarithmic form is going to be log to the base a of b that is equal to n. Okay. Achha. And you know that this base should not be equal to 1. The base should be positive. The one whose log is being found, that should be positive. These are the conditions over here. Then there was a rule that you have done that if you find the log of 1 with any base that is always equal to 0, then you also know that if you have uh, log whose base and this matrix are the same, so that is going to be equal to 1. Then you also know that if you have log to the base a b raised to power n, you can write it as n log to the base a b. So these are the rules that you are already familiar with. Now today we have to talk about some very famous logarithms with maybe you can say with the famous bases. Okay, the first logarithm that is very famous, that is used a lot, that is known as the common logarithm. Okay, this is called the common logarithm. Your calculator has a log key. There's just written log, or sometimes there is written LG over here. That is the common logarithm. A logarithm whose base is 10. Okay, when the base is 10, that is the common logarithm. So since your base 10 is commonly used in the daily life, so that is why we call a logarithm with the base 10 as the common logarithm. So if you have log to the base 10 of a, for example, you can simply write it as log a. Okay, there is no need to write any base over here. Okay, so if there is no base written with any log, so this is, you must understand that this is a base 10 logarithm. Okay, like in the third forms, if you have something like this square root, there is nothing written over here. Okay, normally, for example, if there is the, I mean, cube root of a, for example, so we have to write a chota sa 3 over here. That means there is the cube root of a. If there is a fifth root of, let's say, b, you have to write it like this. But for the square root, now this actually means a raised to power 1 over 3. This means b raised to power 1 over 5. But this is x raised to power half. There is nothing written over here because this is used a lot, this under root x. So there is a special notation for this under root x. Similarly, this base 10 log is used a lot. So whenever we write log x, this is clear that this is basically log to the base 10x. That is why if you have log 10, guess what is the value of log 10? Yes. What is the value of log 10? Can you find this from the calculator, Hassan? Log 10?
Sir, I don't calculator near me.
That will be equal to 1. Okay. If you use your calculator, log 10, if, your answer will be equal to 1. Okay. If you find through your calculator, you must, just a minute. Now you have log 100, let's say this is log 100. Can you tell me what is the value of log 100? Hmm? Yes, Hassan, what is log 100?
The log
This
100 is 2.
this should be 2. Okay. Now you see, you can also prove that why this is 2, because this log 100, you can write this as log 10 square, है ना? This is 10 square, and you can move this power to this coefficient here, so this becomes 2 log 10, and there is a base 10 over here that we don't write because of being a base 10. Okay, so you see this log 10 10 becomes 1, so that is going to be 2 into 1, so that is going to be equal to 2. Okay, so that is equal to 2 like this. Okay, and one more thing, If you press the log inverse key, okay, just press this, you will see that this will be equal to 10 to the power. Your This would appear on the screen of your calculator. That will be 10 to the power. Okay. You know what is the reason for this? Look at this. If you have 10 square, that is going to be equal to 100. Now let's write its logarithmic form. This is log 100, that is equal to 2. Okay. And then as in your trigonometry, if you have sine x that is equal to zero point 0.5, and then you say that, okay, x is going to be sine inverse of zero point 0.5, okay? When you take this sine to the other side, that becomes the sine inverse of zero point 0.5. Similarly, you can shift this log to the other side as well. So this will become 100 is equal to log inverse of 2. 100 is equal to log inverse of 2. Now you see that here is this 100 equal to 10 square, and this 100 is equal to log inverse of 2. So that means log inverse of 2 is 10 square. So if you have log inverse of x, that would mean 10 to the power x. You can check this from your calculator. If you have calculator, find log inverse of 2, you will see that your calculator will give you the answer equal to 100. Can you confirm that? You must have checked from the calculator that log inverse of 2 is going to be 10 square, and that is going to be equal to 100. So the first logarithm that we study, that we use a lot, that is your common logarithm, okay? And this is a logarithm with the base 10, okay? That is a logarithm with the base 10. Okay, the next logarithm that is used a lot in mathematics, in fact, in higher mathematics, that is the natural logarithm. Okay, the natural logarithm. This is a logarithm which has a base e. That has a base e. Okay, so this is, for example, now this E is a very famous number right now. This is beyond your scope, because beyond the scope of your syllabus to talk about this E. So just like, just remember that this E is a number like you have pi, okay? So this E is also a very famous irrational number. So if you have log to the base E of x, this is written as ln x, and this is read as, pronounced as the natural logarithm of x. Okay, if you find somewhere written something like this, ln2, so that means the natural logarithm of 2. Okay, therefore if the base is e, so what do you think, what should be ln e? Hmm? This ln e is basically same as writing log to the base e e. So you see these both are same, so that is equal to 1. Therefore, the natural log of e is also equal to 1. Okay? Now, if you have the calculator, you see if you have ln x, that is equal to 2. And if you write x equal to ln inverse of 2, you will see that your calculator will be showing e squared. Just write this shift ln 2 in your calculator, and you will see that this e square will be appearing there.
Yes, sir.
And so this E, and you can see that, please tell me what is this ln inverse of 1? That is basically your E is for 1. And this is a number which is, I think that is 2.718,
18281
yeah,
228. Yes, sir.
281. So this goes on like, this is an irrational number. So that is the value of E basically. Okay? This is used a lot in banking, or I mean, where you have to calculate the growth kind of thing. So this is used there a lot. Okay. So that was an introduction of your natural log and the common log. Now, suppose if you have to solve an equation. Now, suppose there is a question which is 5 raised to power x, that is equal to 9. Okay. You can solve this taking any uh, logarithm with any base, okay? For example, if you write it as log 5 raised to power x, like applying log on both the sides, okay? One student is going to apply this, so this becomes x log 5, that is equal to log 9, okay? So Hassan, you get log 9 over log 5, okay?
Right.
And if, for example, if I solve this, I would prefer applying the natural logarithm on both the sides, okay? This is x ln 5 equal to ln 9. So x is going to be ln 9 over ln 5. Uh, you can try both of these, you will have the same answers. Tell me what is log 9 over log 5? Mhm. Yes,
Sir, log 9
divided by log 5.
divided by
Log
ln
5. Log
5.
5. Oh, you're using ln or log?
So ln
Okay, tell me what is the answer.
1.36521238
1.37. You will see that if you use the log instead of ln, you will have the same answer. That will also be 1.37. Writing this correct to three significant figures. Okay, so I have given you a brief introduction of the natural logarithm and the common logarithm. And next time we'll be practicing questions, uh, practicing these logarithms onto the exponential equations. ठीक है?
ठीक है सर.
Hmm.